All right, hello class. This will be Unit 7 on conics. And we'll be starting out with circles. By the end of this lesson, we will be able to graph circles and write equations of circles. The standard equation for a circle is of this form right here. The quantity x minus h squared plus the quantity y minus k squared equals r squared, where hk is the center of our circle. So in this example right here, the center is the origin. So for hk, it would be 0, 0. And then r is our radius, so this length from the origin to the point xy, that distance is r. And so to find that, we take the square root, and then we get that equal to r. And this stems from Pythagorean's theorem, where it's a squared for x, y squared is b squared, and r squared would be c squared. So it's of the same form there. Starting with the first example, graphing the circle x squared plus y squared equals 36. To make it look like the form that we see up here, minus h minus k, this would be x minus 0 squared plus y minus 0 squared equals 36. So the center is at 0, 0. So that's at the origin there. And the radius, well, 36 here, that's equal to r squared. So to find the radius, we square both sides, or take the square root of both sides, and we get r equals 6. And some of you may be thinking, well, wouldn't it be plus or minus 6? No, since we're taking, or just finding the distance. So since we're looking at only the distance, it'll be strictly positive. So the radius is 6 units away from the origin. So that's 6 units, that's 6 units, 6 units left, and then 6 units down. So all of those are 6 units away. So from the origin to any point, our radius equals 6 units. And then the diameter all the way across, well, I guess the point's down there, that would be double r. Next, graphing the circle again. Now we have some points here that are not set at the origin. So for h and k, we do the opposite because it was of the form x minus h, but h is negative 2. So when we minus a negative, that's a positive 2. And then over here, we have minus k. Well, k is positive, so it's minus 1, so it's a negative 1. So our center is 2 units to the right and 1 unit down. That's our center. And then again, the radius, r squared equals 16, since it's of the form up here, r squared equals 16. Now we can take the square root on both sides again, r equals 4. 4 units away from the center. 4 units to the right, 1, 2, 3, 4 units up, 4 units left, 1, 2, 3, 4 units down. And then we do our best to draw a really nice circle. Nice. And I have circle assist on, that's really nice. Reiterating, r equals 4 units away from the origin. All right, now we're going to be working backwards in a sense. We have the graphical representation of a circle, and now we want to write the equation of a circle given the graphical representation. So first it asks, what is the center? And so we can see that the center is located at the origin. So that's 0, 0. And the radius is 1, 2, 3 units away. 3. So r equals 3. And when it's of the form x squared plus y squared equals r squared, well, if we square both sides, 3 squared is 9. So this would be the equation centered at the origin with a radius of 3 units. Example 4, write the equation of the circle with center at -1, 3 and a radius of 4. So the center will be our HK and the radius is 7. So when we plug the values in, we have x minus h, -1, squared, plus y minus 3 squared equals r squared, so 7 squared is 49. So now just to simplify, x minus a -1 is x plus 1 squared plus y minus 3 equals 49. All right, in this example, we want to write the equation of the circle with the center at the origin and goes through the point 1, 4. So when it's centered at the origin, that was 0, 0 for our HK values, and it goes through the point 1, 4. So this is some point x, y. So now we can plug those values in when it's of the form x minus h squared plus y minus k squared equals r squared. X equals 1. H is 0, so I'm just going to leave it. Plus y is 4. Again, here k is 0, so I'm going to leave that. And we have not found r squared yet. Now we can simplify. 1 plus 4 squared is 16 equals r squared. So 17 equals r squared. You could solve for r, but we have enough information to write the equation. It was centered at the origin, so it's of the form x squared plus y squared equals, and we found r squared to be 17. Example 6, write the equation of the circle with center at 2, -3 and goes through the point 6, 3. So when it's the center, this is our H and K. Oh, I don't like how thin that is. And then this is our XY. Well, that's weird, isn't that? So when we plug values in, you know what, I'll write the standard form again. X minus H squared plus Y minus K squared equals R squared. Plugging values in, we have 6 minus 2 squared plus y is 3 minus a -3 squared equals r squared. Simplifying, we have 4 squared plus 3 minus -3, so 3 plus 3 is 6 squared equals r squared. So 16 plus 36 equals r squared. 52 equals r squared. Again, you could solve for r by taking the square root of both sides, but we have enough information to write it. I'm going to write it off to the left over here. So the standard form is x minus h squared plus y minus k, but it's minus a -3, so it'd be y plus 3 squared equals r squared, which was 52, and then h and k were found at the top. I believe this is our final example. Yep, our final example here. Graph the circle. First thing to note, they all have a common factor of 6. So my first step would be to divide both sides by 6 so that we get x squared plus y squared equals 6. And when it's of this form, x squared plus y squared, if we remember back, that means the center is at 0, 0. So the center is here. I'm going to erase these. And then we might be tempted to think that 6 is our radius, but since it's of this form, we have it so r squared equals 6. So now when we take the square root of both sides, r equals, oh, look at that, I already have it pulled up. Oh, nope, went away. Square root of 6. We'll say that's approximately 2.45 units. So now when we plot that, it's 2.45 units away from the origin, which was at, or well, away from the center, which is at the origin. And so now this will be our circle here. You think I can move that? I don't know. I'm going to redraw that. It won't let me. So that's the end of our lesson. The circle should be shifted down, but that's a couple different ways to graph circles, or from the circle that has been graphed, writing the equation. All right, thank you for listening.